Lesson 9.4, negative exponents. So we've had some experience with exponents and what they mean, and now we're going to add negative exponents to the mix. The first thing, and probably most importantly, is that in regular problems that you're going to face, you cannot leave a negative exponent in an answer. That would be like leaving a fraction not simplified or something not in a standard form. So make sure that you do everything you can to remove negative exponents in an answer. The only exception is going to be today. There's going to be a section in your homework that purposely wants you to leave a negative exponent in the answer, and that's just to make sure that you know how to do that and what it means to have a negative exponent. So usually no negative exponents left in the answer, but there will be a small section today that you have to do that. Okay, this first part, it says a to the negative second power is equal to 1 over a squared. Okay, so that's what you should get out of this today. If anything is to a negative power, you remove the negative by taking it to a denominator. Okay, later on in math, you'll find out if it has a negative exponent on it and it's already in the denominator, you would move it up to the numerator. Moving it from one place to the other removes the negative on the exponent. So let's look at this two ways so that you can see how we figured this out. I've got a to the third over a to the fifth a couple of different ways. Let's start with this one. Yesterday, we found out when you divided something with the same base, like a, then all you have to do is subtract the exponents. So this would really be a to the 3 minus 5. And a to the 3 minus 5, well, 3 minus 5 is really negative 2. So a to the third over a to the fifth is a to the negative 2. But let's look at it another way. If I have a to the third over a to the fifth, I'm going to expand this to a product. A to the third is a times a times a. And a to the fifth is a times a times a with a couple more. Anytime you have a fraction and there's common factors from the top to bottom, what are we supposed to do with that? Cross it out, cancel it out. So in this one, I'm going to cancel out that set of A's and that set and that set, removing everything from the top. So when that happens, everything cancels out on the top. You have to, at the very least, leave a 1 there. And on the bottom, I've got a times a, which we would write as a squared. So we started with the same problem in both of those, but we went about it a little differently. So what that means is this is exactly the same as that. A to the negative 2 is the same as 1 over a squared. So that kind of proves that anytime you have something to a negative exponent, if you take it to the denominator, it makes it go away. So the first set of problems say write using a positive exponent, which is what you would normally do. 3 to the negative 4. It just means that you would put 1 over 3 to the 4th power. The 3 or the base never changes. Only the exponent changes to a positive. So m to the negative 2. Who wants to tell me what that should be? Ethan.
1 over m to the second, negative second, to the second power.
1 over m to the second power. Okay, now be careful with this next one. Negative 5 to the negative 3. Jared.
Negative 5 cubed with a 1 on top of it?
With a 1 on top of it? Yeah, 1 over, I was hoping you would go back to that. 1 over negative 5 in parentheses to the third power. So that's going to be a large part of what you do today. Now, I'm going to add a problem to that section, and here it is. 3b to the negative fourth. Now, when I look at 3b to the negative fourth, only the b is to the negative power. If it was written in parentheses, 3b to the negative fourth, well then both of them would be, and that's not what we're doing. We're talking about this one. The 3 is to the power of 1, but the b is to the negative fourth. So to simplify that, you leave the 3 alone, and you move the b to the negative fourth to the denominator, and it becomes positive. So this is how you would simplify that. And you're going to have a couple of those. Questions about that problem? Okay. The next section, write using a negative exponent, and I added other than negative 1. And I want you to try your best not to have just a negative 1. I think there's one problem that you don't have a choice, that it couldn't be anything else. So you have to write a negative 1. But for the others, you can kind of adjust it. So we're going to show you that. First example, 1 over 8 to the fourth. How do you think that would look if we wrote it with a negative exponent? Josh?
It would be 8 to the negative fourth power.
Yeah, and that's all you're going to have to do for your homework for this part, 8 to the negative fourth, until we come to this. 1 over 25. Now, 25 doesn't have an exponent, so normally if it doesn't have an exponent, it's automatically a 1, but I said you can't use a negative 1, so let's think about 25 for a minute. Can 25 be written any other way that might have an exponent in it? Can you think of something you could do with 25? Cheyenne?
5 squared.
Yeah. So what you would have to do on this problem is change it to 1 over 5 squared, and then Cheyenne, now write it with a negative exponent.
5 to the negative 6.
Yeah, 5 to the negative 2. 1/16 is just like that. Kind of have a couple options here with the 16. Octavia, what are you thinking? 1 over 4 squared works, and then writing it with a negative exponent, it would be what? 4 to the negative second. Can anybody think of another way, and both would be accepted, another way we could write the 16 other than 4 squared? Megan?
8 squared.
Well, think about 8 squared. That would mean 8 times 8. And what's 8 times 8?
64.
So a little too big. Can you think of something else, Megan, that might work there? 4, well, it's 4 to the second, which is 16. So something else, 2 to the fourth is exactly right. This could also be 1 over 2 to the fourth. And then Megan, writing that with a negative exponent, what would it be? 2 to the negative 4. Okay, so that could work. All right. Any questions about any of those? Like I said on that last section, there is one that you can't rewrite it any other way, so you probably have to put a negative 1 on it. All right, last thing we're going to do is do some evaluation, and I'll kind of go through the steps here. Evaluate always means solve it out and get a final answer. So we have a couple of them. The first one says 16r to the negative third if r equals negative 4. So I kind of want you to do this in a process. The first thing that I want you to do is I want you to take the value of the variable and plug it into the problem, making this problem 16 times negative 4 to the negative 3. That's the first thing I want you to do, is plug the value of the variable into the problem. Second, negative exponent, I want you to get rid of that. So doing so, 16 stays right where it is. but negative 4 goes to the denominator, and the exponent becomes a positive 3. And then now, multiply it out. You will be allowed to use a calculator at this point. So 16 over, so negative 4 to the third actually is negative 64. When you have a fraction like that and one's positive and one's negative, the signs are different, so it's negative, and 16/64 actually reduces to 1/4. That would be your final answer, negative 1/4. Okay, so following those steps, somebody that hasn't gotten a ticket, 2 to the negative q, if q equals 6. Okay, Ben, you're up. Step 1, what would we do?
Put it at
Q equals 6 right over here,
in the problem.
right there.
Oh. 2, then negative 6.
Okay, that's first thing, and then the second thing,
Change the exponent to positive.
how are you going to do that?
16 over negative. Yeah, negative.
Where'd you get 16 at?
Or, sorry, I didn't get wrong problem.
Okay, so 2 should be what? The second step should be what?
2 over negative 6.
What's to the negative power? In our problem on the right, what is to the negative power?
2.
The 2 is. So that's what has to go with the power to the denominator. 1
over 2 to the negative 2 the negative 2 now.
Okay, it's a negative 6 there.
2 over 6. 2 to the 6th power.
2 to the 6th power. Okay, now at this point you would be using a calculator, but let's do this. 2 times 2 times 2 times 2 times 2 times 2. Ben, what's 2 times 2?
4.
And then that's going to be 4 and that's going to be 4. So what's 4 times 4?
8. I'm sorry, 16
16 times 4.
is 64.
64. So 1 over 64 would be the final answer. And that is simplified.